So, right, so let me get started. Welcome everyone to the inaugural session of the Ontology Summit 2026. So this is the 20th anniversary summit. We're going to be looking at the past, present, and future of ontologies. And so I would like to welcome all of you. This being the 20th anniversary, in fact, in just a little less than 1 month, it will be exactly 20 years ago since the summit began with the Upper Ontology Summit, which was held at NIST. So there have now been 20 summits. That's a lot. I'll try to give some idea, all of it, all of what has been covered in all these summits. In any case, to celebrate this milestone, this year we're going to have a retrospective next week. So have some of the veterans of the summit talking about their experiences. Then we'll move on to current activity and future prospects. So in the retrospective, I'll chair that, but we're going to have Janet Singer, Michael Groeninger, and Steve Ray. And hope to have some really interesting comments from them and from participants. People who come should certainly tell us about their experiences as well. It's an interesting history. I'll try to give some idea of it myself, but we're dependent on other people to give a broader view of all that took place in all of these summits. Then we're going to go on to 4 tracks. These were chosen to represent the summit themes over the past 20 years. Roughly speaking, a quarter of them dealt with ontologies and AI, and then another quarter with foundations and tools, and then interoperability, and finally education, training, and certification. We're also going to have some synthesis sessions. It'll be quite a challenge to synthesize what took place in such a large number of summits, but we'll give it a try. So let me go over all of the summits briefly. The ontologies and AI, and Gary is going to be speaking a little about what's going to be covered in that track. We've had a number of summits that have dealt directly with AI or somewhat more indirectly with aspects of AI. To some degree, almost all of the summits have dealt with AI. So Gary is going to give you some idea of all the different cases in the summits of how ontologies deal with AI. Then I'm going to be chairing the Foundations and Tools track. And I'll be saying more about that when I give the overview of this track later on. As you can see, a number of these summits have been dealing with it, as well as tracks in the other summits have considered foundational aspects and tooling. Now, the original Ontology Summit, the Upper Ontology Summit, is part of Interoperability Week at NIST. And so interoperability is major aspect, the major purpose of ontologies. And so, as you might expect, a lot of our summits have dealt with interoperability issues. So, Todd and Mike Bennett, Todd Schneider and Mike Bennett, are going to be giving an overview of uh, some of the things that are going to be presented in that track. Finally, John Beverly is going to be giving an overview on what's going to be taking place in the education, training, and certification track. This track has also been important uh, for the summits. There have been uh, one summit creating the ontologists of the future that directly dealt with education, and several others that have also talked about the educational training and certification issues. And I'll leave that to John Beverly to talk about. And so, so at this point, I will turn it over to John Beverly. Are you here?
I am.
Great.
That's good to see you guys.
Good to see you. Great.
Yeah.
So
Do you,
give me a moment and
yeah.
I'll make you a co-host.
Oh, excellent. Thank you.
There you go.
Thank you, sir. I'm going to share a slide real quick.
Okay.
I won't take up too much of your time, but a picture is worth 1,000 words. So I have a little slide here going over what some of what we've been doing in our circles through training and credentialing and ontology. So a little bit of background. I studied as a philosopher, but I have a background in engineering, and so I naturally sort of gravitated into the space when I met Barry Smith at Buffalo. I went into industry, working at the Applied Physics Lab at Johns Hopkins as a senior ontologist before circling back, and now I'm here at the University of Buffalo. I came here to Buffalo largely to train people in industry practices, best practices around ontology engineering. And so this is one of the reasons why I'm one of the reasons why we have this master's and PhD program at the University of Buffalo in applied ontology, uh, due to the efforts of focusing on that. I know we need a lot of ontologists. I'm worried about the training in ontology engineering and ontology, just using ontologies in general, especially now that we're in the limelight, as it were. AI has kind of made it clear why ontologies are very important. I worry that if we don't have well-trained ontologists, then what happens in large companies will happen here, which is they will just pull whoever they have to kind of like patchwork a team to do something ontology or semantic related. It will fail, and they will blame the field, not Alex from accounting, because this has happened before. And so we're trying to like up the game, mature the training. The focus here, through that kind of a thread that runs through the proposed sessions here, is going to be an emphasis less on building artifacts and ontologies or knowledge graphs and stuff like that, and more or less a trade craft, best practices lined up with contemporary software engineering best practices, DevOps best practices, in the interest of fitting ontologies and semantic artifacts into existing architectures for things like data interoperability, data quality improvement, AI leveraging, etc. So to me, this is just a piece. We're just a piece in the broader AI puzzle. This is how we should approach things. This is how we're trying to train students to do this. And so at the very top, first session, foundations. This is what we're doing in the UB graduate program. And I'm going to drop some links in here for each of these, so in case I run through this too quickly. But the training program is designed to have students not necessarily become software engineers, not necessarily become like coders or something, but learning the ontology engineering best practices that have been borne out over time from this community and others, and being able to talk to software engineers, being able to talk with people from other disciplines because it's, again, a piece in the broader AI puzzle. So we need to be able to communicate. We focus on these foundational skills here. We get internships, et cetera, so that students can get hands-on training. Some of the places we get internships are right here. So the next session, the hope is to have actual industry application from Kubrick, which is a long-term affiliate or association with UB and our applied ontology program, showing how they have created a pipeline from academia into, in this case, U.S. government contracting space. So they focus on building ontologies and using ontologies for defense and security. And they've learned a lot. They've learned a lot over the years. They've been doing this for decades, right? And so having their team come over and just kind of explore what they find valuable and have found valuable over the years, I think would be very important to convey to the community. I know when I have them come speak to my students, it kind of like lights go off. Like, okay, that's a really important thing to know, right? And sometimes you just have to see it from an actual practitioner in industry coming to tell you why it's important and what's important. Same too, but come kind of leading into more of the contemporary AI landscape is Jeremy, and I've got Jeremy's name. Kubrick, I'm not exactly sure who will come. There are a couple of people, but Jeremy for sure for NAS AI. He's been working with us, Kubrick, and other companies for a while now using ontologies in an AI, agentic AI pipeline. So how exactly do we leverage contemporary resources and research that's going on in this exploding AI space, bubble or not? How do we leverage that in combination with ontologies so we can either improve data interoperability, improve data quality, improve the agents themselves, perhaps just use the AI agents as glue for stitching together other tools that we have or other ontologies we have. The world is kind of your oyster here, and him and his team at NAS AI have learned a great deal about what works and what doesn't. Again, I thought having him come and discuss those best practices or lessons learned from his area would kind of get us up to speed in the modern overview of how ontologies are being used in the AI space, separate from the defense and security side. I will say, and Barry warned me, it's like, listen, this is a group of people who like friction. You like contentious claims. So he told me, go be contentious. I am. I will. In that first talk, I'm going to pitch because this is core to the curriculum. I will pitch what I think it is that makes our field distinct from all other fields. It's oftentimes the case, well, I'll go out and ask people in our community, why is ontology engineering different from data science, different from data modeling, different from conceptual engineering? And I don't get great answers. So spend a lot of time thinking about what exactly it is that makes us distinct. And I have a contentious, but I think correct way of understanding our discipline. And really, contentious stuff aside, I would love to hear feedback from the community. This is a community effort, so I want to put it out there so that folks push back, right? So, because I want it to be common, I want it to be accepted, consensus, and the only way to do that is to reach out to the community and let it run through the gauntlet, as it were. So, I'm gonna pause there because I know other people have things to talk about, but questions, comments, concerns, compliments, let me hear.
Thank you so much, John. Looking forward to your track.
Fantastic. I'm looking forward to being
Thanks.
here. Thanks, guys.
So now we move on to Gary. Go ahead, Gary.
Okay. Um, I need to get my, let's see if I can get to my slides. I'll do it this way. Okay. Is that visible okay?
Yes, there.
Okay. So I'm Gary Birdcross. I'm the co-chair of this track on AIs and ontologies, along with Ram Sriram. And I want to cover a little bit of the history of the summits related to this topic. Ken has already shown that maybe a quarter of our sessions have involved something like that. And on this first slide, let me actually make this a slideshow. That might be, hopefully that's a little bit better. I got a graphic on the bottom. It's actually from the first session. And during that first session, people were talking about the semantics of ontologies, and you see the content and granularity and so forth. They were also talking about practical issues, the pragmatics of how do you govern those, maybe how you educate people, as John was talking about, and so forth. So that's from our past. The quote I have here is more contemporary, and it's more in the flavor of what I want to talk about as background, and also hopefully our sessions will cover this. And so this is from 2025. And the quote is, "We like to think of AI as a challenge to human intelligence, but it's really about how smart AI becoming. It's not that. It's how little we understand of what we mean by knowledge." And I think that's an important issue currently. What do we know about the semantics of knowledge current? So here's an outline of my talk. Whoops. I'm going to provide a fair number of slides on some of the retrospective views and sort of what the summits were about and how it relates to AI at times, some of our issues. The track obviously is an old story part from symbolic AI to modern neural net AI, and it's moving very rapidly, and the intersection of these two is moving very rapidly. So I'll start with a view of the beginning summits, and then move to the more recent summits, which feature more about AI. But the ontological work, as John has pointed out, is still very active and going on and very important. And finally, a brief look at the track mission and the track plan and who our speakers are going to be, just as John had his list. So I'm starting with a slide that was really current when we started back in 2009 or so. This slide actually goes back to around, or the graphic goes back to about the late 90s, early 200s. And it's a view of the semantic spectrum, which has been represented several ways. This is an old slide from, I think, the original summit, which sort of shows on the vertical the movement from weak semantics to strong semantics being represented by things like an OWL language, weak semantics being represented by text and things that are in glossaries and so forth. And the slide also includes some formalism. So the idea was that over time, we're just going to be moving those things that are very informal into forms like RDF and eventually into OWL and things of that nature. And so that's sort of what the idea was at the beginning, although it's been modified over time. So the second slide on this that I'm showing here is from one of my presentations, maybe 5 years ago, when we were talking about the semantic spectrum again, and in terms of harmonizing things. Now, there's a lot going on in this slide, but I'm going to focus on the idea that at the time we were talking about that, we were talking about knowledge graphs as an exciting area, and the idea of the role of ontologies here and how to harmonize ontologies with data into knowledge graphs. And the point I was making in this is that conceptual models plays a large integrative view here. Actually, the summit we had last year on conceptualization and foundations made more of a point about this, and people were interested in that topic can go back to last year. You'll notice also that we featured the idea of interoperability as part of knowledge graphs. That is to say, we have to make the things that go into the knowledge graph work together. That has to be harmonized. And ultimately, the idea is that there's the degree of shared understanding that goes into knowledge graphs. And the strategy now, rather than moving everything up into ontologies and into things like OWL, is that we first need to harmonize each level. You have to harmonize things at taxonomic level. Glossaries have to be harmonized. The definitions, there are many glossaries out there. So the point here was that we try to harmonize the levels now for knowledge graphs, and then we try to harmonize the whole thing. And as part of that, we're harmonizing and standardizing on the meaning of things found at each of these levels. I have one little statement here on the side. Systems may require representations at multiple levels of abstraction beside a single symbolic level. And that's one of the lessons from the series of summits we've had. The first summit, which I'm shown on the next slide here, dealt with upper level ontologies. And the hope was at the time that we would be able to sort of come up with maybe one upper level ontology. That wasn't the case. The next summit moved to the idea of, well, there's many components along the spectrum that go into that. Let's sort of agree on what they are and how to harmonize those. And as we move forward with the summits that were, Ken already said something about these, we've moved on to things that like ontology repositories. We needed that. And I raised the question about whether that has largely been solved. We know that we have good repositories where some of these things are stored, but along the spectrum is a problem or a challenge because we have many components that go into even the ontology, such as the standard vocabularies, and those might not have been stored in the same way. And so importing those and moving them around is maybe still an issue. By 2009, we were talking about ontology standards. That's something that's part of both education and foundations. And we had things like Miro discussed at some of the summits, such as minimum information requirements to specify ontologies, essentially the metadata for ontologies. And again, we've made a lot of good progress on that. Moving to 2010, John has already indicated they're going to be talking about him and Barry Smith. Creating the ontologies of the future was a topic back in 2010. And then moving along these summits, big data jumps out as something that preceded knowledge graphs as a big topic. But now big data takes on a different role in terms of being used to train Gen AIs and large language models too. So that again, the things you read about and that we talked about in 2014 are now have a relevance in that area. And finally, up at the top, we have the idea of interoperability. So these are some of the topics that we talked about along the way and that we'll reflect as other parts of this summit. So my next slide, I wanted to make the point that ontologies and structured knowledge is not always featured as much as it maybe should as part of broad AI. So Bart Selman, for example, in a recent talk as president of AAAI, talking about the state of AI, had a diagram like this in which knowledge and ontologies is not even represented as this period of work. And many of us were working in this time in the 80s and 90s and so forth. And of course, the semantic web came along at this time and so it had a big role and made some contributions, but you don't necessarily see it here. I have a quote about the bitter lesson, which is an AI that Richard Sutton made. And essentially this message about the bitter lesson is something we haven't really talked about it directly at summits, but I think it's really important in today's context. And part of that message was that hand working on things like ontologies which was part of symbolic AI back in the 80s and 90s, was superseded by things like machine learning, which became very tractable with more powerful computers and some developments in algorithms and so forth. So that the bit of lesson is that you try to make use of that power. And I will argue, and I think our tracks will cover some of that, is that modern AI, the Gen AI aspect of it, provides tools which actually can help development and improvement in ontologies. And of course, it works the other way, where ontologies can indeed turn around and help improvement on Gen AIs. So here is the second historical view, which brings us to the more of the topics on the summits which directly addressed AIs in many ways, starting with 2017, which was called AI Learning, Reasoning, and Ontologies. And what I have here is just two of the topics from my track on that session. We had a track on using automation and machine learning to extract knowledge and improve ontologies. That was some Carnegie Mellon work, for example, and others. And that can be updated. That will be updated in our track because now we have Gen AIs, which actually can be used to semi-automate some aspects of developing ontologies and knowledge graphs. We also had a talk by Alexandro Altomari, who's at Bosch, which was called From Machines That Learn to Machines That Know. Obviously, that is something that is actively engaged as part of the conversation now. Some of our other relevant summits here include the idea of talking about context, where you need to take into account the intentional context of cognitive agents, and that there the idea is that things get more cognitive. And indeed, that was discussed last year too. We had explanations, including the role of common sense, and the idea again is that ontologies help provide explanations and that are needed because Gen AIs typically don't do a good job on that. I mentioned knowledge graphs before. They obviously leverage ontology to some degree, although in some cases it's light. And then we'll jump to 2024, 2025. 2024 is a very direct antecedent about what the discussion will be in this track this year, where we're talking about neurosymbolic techniques that could be used with ontologies and knowledge graphs. And actually, we'll leverage some of the ideas of the pros and cons of what are the limits and advantages of Gen AIs, and also the idea of hybrid views is, I think, is a very important topic where you can combine these two. And indeed, as some people have said, we were waiting a long time to get this essentially way for AI to do very fast processing, intuitive processing, and so forth. Now, when we have that, this actually can be leveraged to help symbolic AIs quite a bit. And that's part of the hybrid views. Last year's summit, I essentially stresses, among other things, the importance of conceptualization and not just formalization. If you formalize the things that aren't well conceptualized, you lose interoperability and things of that nature. So for all of these, I think we have some good historical views that will essentially be added to. So if the theme is yesterday, today, and tomorrow, this is a lot of the yesterday and a little bit of today, and we'll get to more of tomorrow. This slide, I just wanted to point out that work on things like even upper ontologies have not been lost. There's been a lot of standardization, BFO, which we've heard a lot about in past summits. The Common Core ontologies are part of the advancement, and the build ontologies for businesses, BOB Foundry, for example, is just another example of how things like foundational ontologies and domain ontologies have advanced and become useful. I think we're going to have somebody talk about industrial ontology foundation in another foundry in another track. And lastly, on this slide, I wanted to sort of just again summarize where I think we're going in terms of the future. Is that we're getting a lot of things from learning from data as part of a Gen AI, but to get to the hope of real intelligence systems, we're going to have to leverage that with knowledge and experience. And there's a lot of learning, not from data, but also experience that people are looking at now. And of course, then there's the whole point about reasoning. So this slide summarizes a few of the points, again, making the argument that ontologies, even upper ontologies, still serve an important role in the last 5 years. So one is the role in semantic interoperability, and then we've talked already about the idea of harmonizing vocabularies, allowing things for data exchange. This is the semantic spectrum issue again. There is still work on supporting knowledge representation, and the last summit in 2025 had a lot to say about this in terms of conceptualization and formalizations. So the importance of structure. This also allows things like explainability, which is needed for Gen AIs, which are weak in that. I've mentioned again the central role of hybrid ontologies, which 2024 featured, and we'll have an update on that. And finally, I think it's important to update and address the idea of the limitations of current Gen AI, which was a discussion topic in 2024 and 2027. So this gives you an idea of just some of the things from the past that also can be updated and are still important. So I now have a few slides on the mission of the track. With that, as we've already covered some background, I talked about the 2021 and 2024 summits, advancements in machine learning and knowledge graphs have proliferated, and many of these now can support knowledge graphs and the building of ontologies. So we would look at how are they helping and what role can ontologies play in hybrid systems. I point out that knowledge graphs and ontologies are typically developed independently, raising interoperability and communication difficulties when we're trying to merge things, such as in knowledge graphs, and even build interoperable ontologies. And so there is an important harmonization relationship between these, and Gen AIs actually, I think, can help a bit in some of those type of things. The fifth point is the major impediment to harmonization is the relatively poor quality of natural language definitions in many ontologies that become axiomatized, so that although they've been axiomatized, they may not have the same axioms as some things that are in related ontologies and knowledge graphs. And so there's a problem that maybe starts at the lower end of the semantic spectrum where definitions, and we need some improvements in Gen AI, I think, can help. And finally, there may be ethical issues that we need to consider along the way as we discuss modern AI. So this is essentially a replication of a slide I had in an earlier summit, but I think it's still important because now we're at the area where we're getting systems that are computational systems that combine knowledge, reasoning, and learning. And what's a perspective on how, what's the best way to do that and where the issues are. And so here's a quote from Leslie Valiant, which I'll read. The aim is to identify a working at looking at and manipulating common sense knowledge, making it consistent with and which can support what we can consider to be the two most fundamental aspects of intelligent cognitive behavior: the ability to learn from experience, which is a little bit different than just learning from data. It's a little bit more challenging, but it's an important area, and the ability to reason from what we have learned. We are therefore seeking a semantics of knowledge that can be computationally support the basic phenomena of intelligent behavior. So I think that's where we're going. Yesterday, today, that's the tomorrow issue, which this goes back over a dozen years or so, but it's still very important. Well, the bottom line is pay attention to formally define computational semantics and real-world semantics, as well as relationships as part of common sense intuitive explanation. Okay, so a little bit more on the track plans. So I basically think of this starting with maybe 4 areas, which reflect what we talked about 2 years ago as part of a summit. Machine learning and Gen AI support of knowledge graph ontologies development. And you see a diagram on the side here, which sort of illustrates how some of that is done. Then, of course, the important topic of ontology support for machine learning and Gen AI. Then the hybrid idea of new symbolic AI. We'll have several speakers on that. And then maybe the issue of what semantic knowledge means, the real world semantics, learning via experience in AI, as an important topic for the future. So our approach is pretty standard, that we'll have a bunch of practitioners who have worked in these areas, and I have a list of those later. We will be talking about building on past ontology summits. Ram and I will actually be talking about it in 2 weeks. And we hope to provide a useful context for later tracks, such as the one that John So has talked about, which will talk about pros and cons of Gen AI and an AGI topic. And so we actually have speakers who might address some of that. And of course, we will work on the synthesis and the communique. So here's right now our current plan. In 2 weeks, March 7th, Ram and I will each provide some more material on this topic, along with some objectives and issues. Then we have a talk from Randy Goebel, who's at the Alberta Machine Intelligence Institute. He's interested in a bunch of things, can talk about the bit of lesson, explainable AI. He knows something about the Alberta plan to produce sort of a long-term view based on learning from experience to an AGI topic. One notes along the way that Turing actually talked about things like that, such as the Alberta plan is looking at, which is talking about using a child machine, which was subject to an educational process along the way. People don't necessarily refer to Turing's topic on that as much, but we are getting to the point where we might have some start on that. Our third speaker will be Pascal Hitzler, who's at Kansas State, and he's well known for working in this hybrid area. And as a placeholder, the topic might be ontologies in the era of large language models. And then lastly, currently we have, after him, maybe combined sessions with Louis Lamb and Manas Aguar talking about hybrids again in knowledge graphs. And so that's basically the coverage of that. I have a few more slides as backups in there that people can read. And again, if there are any questions, let me know now, or maybe we have time at the end of the session to talk, to have more of a discussion.
Thanks, Gary. Next, we have Mike Bennett. Can you?
Okay.
There you go.
Yeah. So I didn't bring slides. So is there anybody else from the integration track here as well, or do you want me to speak for that whole track? Oh, Robbie's here. So hey, Robbie. So yeah, the integration track, we'd be looking at various aspects of use of ontologies in integration. Would be that data integration, reporting, business, and so on. My particular talk will be on the financial industry business ontology from a more historical perspective. So, FIBO, financial industry business ontology, was originally created to solve the integration problems in financial institutions, particularly when we had the financial crisis in 2008. Most banks, all banks, had all the data they could possibly need, but it still took them some weeks to turn that into actionable knowledge and figure out what their exposures were to different parties and so on, because data wasn't the problem. It's being able to integrate it and apply meaning to it. So we built this ontology for the financial industry. It's still in use. We built it for integration, and integration is kind of a data problem, but to truly integrate data, you have to go beyond data to models of the real world. What is a mortgage-backed security? What is an asset-backed security? What distinguishes one from the other, and so on. And so we learned a lot of lessons. I'll focus in that section on the lessons we learned on the different styles of ontology, the different schools of ontology thought, and so on. There's emerging bigger consensus now than there was then about how some ontologies, every element represents something in the world, and some, every element represents some data. And in the semantic web style of ontology, which the OWL language is typically used for, you have ontologies that are optimized for reasoning. And for example, those tend to discourage having deep subsumption hierarchies, whereas the model of real things will have deep subsumption hierarchies because that's how reality is. So we'll talk through some of the lessons about what we learned from ontologies, from trying to do an ontology for integration, and then having various people turn that into a semantic web style of ontology, which was really a completely different thing, and kind of what we learned from that and what we've been doing since then. So that's what my talk will be, and hopefully that will set the scene for kind of some of the other talks on that. I don't know, Ravi, do you want to add anything about any of the other talks in that track? You're on mute.
Mike Todd is going to speak today on little overview of interoperability
Great.
after
Good.
you finish.
Okay, well, I'm done. I was just giving you a sneak preview of what my talk was going to be. So that's it from me on that. Thank you.
Wonderful, wonderful. Can you want Todd to
Todd, are
speak
you
now?
going to give
Todd?
Todd?
I'm ready, Kenneth, if you are.
Are you giving a
Hello?
presentation?
Yeah, Todd
Or is it
Schneider
Ravi?
is going to give the presentation. I forwarded you the PDF of that to you, Ken.
Yes, I have. Oh, Todd is, yeah, Todd's doing it.
I'll be quick. So Ravi and I are running the track on interoperability, and I just wanted to sort of set the stage for the talks that you will hear. Mike just described what he's going to present, and it fits into the overall notion of interoperability. So just a quick bit of history, since Gary gave us a very extensive review of that. I went through all of the Ontology Summit communiques, and I found that there were only two communiques that did not mention interoperability. Those happened in 2013, 2014. And as you can see in 2016, the title of interoperability was, the title included interoperability. So I know everyone has some notions of interoperability. Gary talked about it, and Mike just made very explicit reference to it. And there are different notions of interoperability. And more importantly, the natural language definitions have sort of evolved over time. So I'll let you look at these at some later time. This one from the New Oxford American Dictionary talks about computer systems, or if you like, information systems being interoperable. And then from Wikipedia, they expanded it to just systems in general, not just computer systems. But these definitions have a bias towards information. And then in the 2016 communique, they talk about arbitrary entities now, and more importantly, the notion of being able to operate together. So here we have now expanded or extended the scope of what we want to consider is applicable for this notion of interoperability. So interoperability as a notion or as a concept has a scope, and it can apply to physical entities, to organizations, their operations, and of course, for this group, communications and interactions. And of course, language, syntax of the language, the semantics of the language can be interoperable or not interoperable. And then, of course, we get down to information and data. All those things have the notions of interoperability associated with them, depending on the context. And then there's also a scale to the notion of interoperability in general. Who or what needs to be interoperable and how much needs to be interoperable. This comes down to if you like, engineering issues, and most importantly, how much money do you have and can you afford it? And where do you need it and when do you need it? So it takes time to do these things and it costs to do these things. And those have to be considered when you're thinking about the overall notion of interoperability. And then, of course, for what we're interested in here in Ontolog is semantic interoperability, but that also has a scope. Are you worried about your own little domain? And of course, you get down to application ontologies where you're going to use them for making your data more comprehensible and more useful, which is, as Gary pointed out, now a very significant problem. Or are you talking about cross-domain interoperability? So you may have lots of ontologies for your little domain, but can you talk to another domain that you have to interact with? And when you get to industry and business, this is a real serious challenge. So you may have a beautiful ontology for metallurgy, but now if you have to go to marketing or you have to go to the uses of your metal products, your information systems may not be able to communicate adequately, if at all, with other information systems in different domains. So when we talk about interoperability and semantic interoperability, we can have ontologies that work in a domain or maybe even a reference level, but then you may not be able to cross your domain or your ontologies for your domain with other ontologies in a different domain. And of course, as Gary pointed out, this is where upper ontologies can become useful. That is, having a common basis may not guarantee interoperability, but it can certainly facilitate the minimization of differences you have to address. And now, this is another more recent definition of semantic interoperability, and it comes from the second version of the scope model for exploring interoperability, which is not yet available, but we have a rather extensive discussion of this notion, and it's based on a rather simple-minded model of communications, i.e., there is a sender and there's one or more receivers. Now, I understand that there are many models of communication, and they can be quite sophisticated, but in terms of trying to explore interoperability, this rather simple-minded model of as I said, a sender and one or more receivers is sufficient for what we'd like to do. So in this case, we're talking about using information from a sender to receiver so that, and of course, the important term here is interpretation. The receiver can interpret the content of your communication in a fashion that's not too dissimilar from the sender's intent. So you can study that at a later time if you want. And at some point in the not too distant future, this new version of the scope model will be available. So we have three speakers. You heard from Mike Bennett. He told you what he will talk about. Ravi is one of our speakers. And then Will Sobel will talk about the use of industrial standards and how they fall short. And in particular, I believe we'll start addressing how the process of developing ontologies can aid in the creation and maintenance of standards, in particular industrial standards. And that's all I have, Kenneth.
Great. Okay. So now we'll move on to the last of our tracks. It's the foundations and tools. So that's there we go. This is not working. Okay. So the history of this is interesting. The first two summits, and to some extent even the third, were foundational. Although, of course, foundational issues run through all of the various summits. But especially in those first two, where there was an explicit goal, an objective to determine what an ontology is. And it's interesting that the most recent summit has also been foundational. So we come kind of full circle, starting out with foundational issues and then most recently coming back to these foundational issues. So what are those issues? I mean, basic one is, of course, what is an ontology? And how are ontologies related to other notions, conceptualizations, theories, semantics, etc. How can one specify, verbalize, and visualize an ontology is certainly important. And then how effective are these ontologies in practice? That was a very common theme throughout the summits. One aspect of ontologies is supporting reasoning, although it doesn't seem like that's always very important. But ontology should indeed support reasoning. How do ontologies relate to the world and to theories about the world? How can one find existing ontologies that are needed by an application? This was the topic of the third summit about repositories. So these are all very important issues, all very foundational issues. And we have been dealing with them, and so we're going to be going back to them again and looking into the future for what we still need to do to clarify all of these issues, which is how do we address them? There are many different levels at which you can consider the impact of an ontology. And then we came up with this idea of how to organize and address using these question words. So in at least one summit, the summit was organized around these words. So this is a very interesting framework for dealing with the problem of addressing any issue, actually. And we plan to have 3 sessions from the 1st of April to the 15th of April. We have only scheduled Mark Musin so far, but we expect to be able to fill out this track and get some interesting speakers to develop this subject. And I'll end with a little quote. given that we've come full circle, starting with foundations and then ending with them. This is from T.S. Eliot. We shall not cease from exploration. And the end of all our exploration will be to arrive where we started and know the place for the first time.